Well, class, I know you're disappointed we didn't see each other face to face, so I made this little recording so you can kind of keep up. We don't have to spend tons and tons of time going back and back and back so that we can get through everything we need to do for upcoming classes. So first off, there's a drill here I'd like you to try and see what you can come up with. The lines that you see with the right angles are your altitudes. You'll recall an altitude goes from a vertex perpendicular to the opposite side. That's what I'm looking for in this case. So I'm going to pause for about 5 seconds or so, but then you can pause this for as long as you'd like and complete the drill, and then come back to the video. So hopefully you broke this down to be 4 and 4 because it's an isosceles right triangle. And then our isosceles triangle start, and then we drop in that altitude. So then we're going to use Pythagorean theorem. And we're going to plug in our values. And we're going to get a squared equals 9. So a equals 3. So that's our altitude. And then if we want to find the area, that's 1/2 base times height. Our base is 8. Our height is 3. So we're looking at 12 centimeters squared. Now you want to do the same thing for the next one. So again, I'll give you a second and then I will be back. So this time we have an equilateral triangle. So we want to put 60 degrees, 30 degrees. This would be 6, and then we have 3 and 3. So if you use Pythagorean theorem, a squared plus b squared equals c squared. Let's say we have 3 squared plus b squared equals 6 squared. So b squared is going to be 36 minus 9, which is 27. We take the square root, so b is 3, square root of 3, and that is our altitude. And again, you can find the area, but we're more concerned right now about finding these values. So I have another drill question for you, so let me bring that up. See if you can solve these questions here. Again, I'm going to pause for a couple seconds, but you can pause the video as long as you need. Good luck. So to solve each of these, hopefully the first thing you did was divide each side by 2 and get x equals 4. And then divide by 2.5 and x equals 4 again. Now we want to get rid of the square root, so we square both sides. So x equals 36. Then again in 4 we're dividing by 5. So x equals 8. We divide both sides by 3.5. So x equals 6.5. I know it's a little hard to read that. Now, for number 6, it kind of combines both, so we're going to divide by 6 first. That leaves us the square root of x equals 16. We then square both sides. So then we have x equals 256. So again, hopefully you were able to get all those, and this is going to come into play as we move forward with our lesson today, being able to solve. So let's look at our objective. To review properties of special right triangles, and I want to remind you that Tuesday, those 10 SAT questions we've talked a lot about, we are going to have a chance to redo those, so you're going to want to make sure that you know how to do all 10 and can get all 10 answers. And then right now your test for Chapter 5 is scheduled for March 2nd, and no matter what, I don't think that date's going to change, so just be aware of that. Alright, so for homework, after our quiz, you were supposed to fill in this information. So the first thing hopefully you notice is that each of these is an isosceles right triangle. So when we talk about the x and the y in each one, since it's an isosceles right and we already have 90 degrees, We take and subtract that from 180 divided by 2, and we get 45 and 45. Because it's an isosceles right, we should have gone ahead and marked this side a 3, and then you could also mark this side a 5, and then by doing Pythagorean theorem, you should have been able to come up with this 3 root 2. And then again, over here, we should have gotten 5 root 2. So hopefully you were able to do that, but let's look at some more examples. The second ones, again, you have an isosceles right triangle in each, so both are 45. Since the legs are 6, z should be 6 root 2. And then also (11 root 2). So this is what we would consider a 45, 45, 90 triangle. So 45, 45, 90 triangle. Then you had to work with your triangles here, which were equilateral. So let's take a look at one of these. And we'll choose a nice color here. So right here we should have had 60 degrees. And for these, 30 degrees. So this is going to be looking at a 30, 60, 90 triangle. And you should have gotten that y was 8, m was 4, z was 4. And then hopefully you got h by doing the Pythagorean theorem, and h should have equaled 4 root 3. Okay? And again, 60 over here, 30, and then of course 90 as well. Alright? So when we get to the second one, again 60, 30, 30, 60, 90, 6, 3 and 3, and then your h should have been 3 root 3, which you can use a squared plus b squared equals c squared if you need to, and see that you have the square root of 27. And then two more. Again, hopefully you got 10, 5, 5, and then 5 root 3. Alright, and of course 30, 60, and 90, those aren't changing, so those should still be the same. And then again here we have 24, 12, 12, and our h, 12 root 3. So the whole point of this was for you to be able to see some of the formulas that we want to work with. The first is the 45, 45, 90 triangle. Okay? And in the 45, 45, 90 triangle, the hypotenuse is root 2 times the length of the leg. So what I'd like to see every time we do these problems is, I want you to use this formula that you see right here. Okay, this 45, 45, 90. So the first thing you'll do is write that down. Then you write a equals x, b equals x, c equals x root 2. And then you say to yourself, which piece do I know? Do I know a? Do I know b? Do I know c? Okay, and remember, c is always opposite the 90 degrees. That's why it's x root 2. Don't get caught up in the letters that are on your drawing. Get caught up in the information in this formula. So every time we're working with a 45, 45, 90, and we have to know it's 45, 45, 90, we want to do a equals x, b equals x, and c equals x root 2. And then for our 30, 60, 90, we have the hypotenuse is twice as long as the shorter leg, and the longer leg is root 3 times the shorter leg. So that formula, 30, 60, 90, A equals X, B equals X root 3, and C is equal to 2X. Now I know that you're probably wondering, how do I know which one's A, which one's B, which one's C? That's why I have this information here. Okay? Because A is always across from 30 degrees, B is always across from 60 degrees, and C is always across from 90. So again, you're going to write this formula down, and then you're going to plug in. Okay, so now we're going to try and see how you do with a couple of these, and then we'll kind of go over it and see what you came up with. So first thing you want to do is recognize, do you have a 45, 45, 90 or a 30, 60, 90 triangle? Write down the formula, plug in for what you know, solve for what you don't know. So you can pause the video and complete numbers 1 through 12 on 5-4 examples, which hopefully you've downloaded along with this lesson. So here you go. For 1 through 6, we have our numbers here, 62, 62.2, and 62.23. But when we came down to this other one, number 4, I should recognize, oh, this side is congruent to this side, and it's a right triangle, so that is 45, 45, 90. So I say A equals X, B equals X, C equals X root 2. And then I come back and I say, I know one of the legs is 16, so I plug that in. And then the other one has to be 16, which means the hypotenuse is 16 root 2. So that's the value of my X in my picture. That's why when you write down the formula, don't get concerned about what's here compared to what's in your diagram. Just fill in and then match it up. In number 5, you have X equals 50 root 2. Again, 45, 45, 90. And 6, very similar, 13, 13, and 13 root 2. Now, I'm going to do starting and do each column. So we look at number 7. So the first thing we ask ourselves is, what kind of triangle do we have? And it's a 30, 60, 90. So A equals X, B equals X root 3, C equals 2X. And then we say to ourselves, which piece do we know? Well, I know C is 4. So I don't change my formula. I just set that equal to 4. Well, if 2X equals 4, that means X equals 2. So there's my A. And if A is 2, B is going to be 2 root 3. So that's going to look like this. Now we go down to number 10. It's a 30, 60, 90. Do I know A, B, or C? In this case, I have the value across from the 30 degrees. So that means that I know that I have A. So A is 3. Well, if A is 3, B is 3 root 3, and C is 6. Let's look at another one. Number 8. What kind of triangle it is? 30, 60, 90. Which piece do I know? Do I know A, B, or C? Again, I know C is 10, so I set it equal to 10. And then that means if I solve for X, X equals 5, that's A. And then B would be 5 root 3. So again, don't get wrapped up in the letters that are on the drawing. Worry about what's in your formula and what do you know. So we come down to 11. This is where it starts to get tricky, so you got to pay close attention. In number 11, it's a 30, 60, 90 triangle, but this time I got what's across from 60 degrees. And if we recall, that is B. So we're going to take this whole thing and set it equal to 3. Alright, so we were on number 11. I know the video stopped, so hopefully you got to the second part. And we have a 30, 60, 90, but this time we are having B because it's across from the 60 degrees, so it's going to be right here. And what we have to realize here is that it's going to take a little bit of work to solve for x. So we're going to do that. And what we do is we say that x root 3 equals 3. And then just like in our drill, we're going to divide both sides by root 3 and solve. And we get 3 over root 3. And you can leave it that way. That's fine. I know it looks a little strange, but it's good. And then 2 times that would be 6 over root 3. So again, 30, 60, 90, write down your formula. Plug in for what you know, solve for what you don't know. Don't worry about the labels on the actual pictures. Okay, just fill in the formula. All right, here we go with 9 and 10. Number 9. Again, you know what I'm going to ask. What kind of triangle it is? Hopefully you said 30, 60, 90. Which piece do we know? A, B, or C? We know C is 5. Okay? So that means A is going to be half of that. So that's 5 halves or 2.5. And B is going to be 2.5 root 3. All right, number 12. 30, 60, 90. A equals X. B equals X root 3. C equals 2X. Which one do we know? We know B again. That's 8. So take a second. Solve for X. Did you get 8 divided by root 3? That's our A. 2 times that. That's 16 over root 3. Again, I know it looks a little strange, but you can leave it that way. Alright? So again, you're going to have to practice these, and you're going to need to know the formulas. Again, you can only use them if you know it's a 45, 45, 90, or it's a 30, 60, 90. Okay? So again, before we get into our last examples, let's review our 2 formulas. 45, 45, 90, A equals X, B equals X, C equals X root 2. Find out what you know, solve for what you don't. 30, 60, 90, A equals X, B equals X root 3, C equals 2X. Always across. A is always across from 30 degrees, B always across from 60 degrees, C always across from 90 degrees. So now that we've done that, I want you to try these problems, and I've actually made a handout that goes along with these problems where all you have to do is plug into the formula. So try these, and then we'll go over those afterwards.